You're sitting in the loudest airport terminal on Earth. Engines roaring, kids screaming. The guy next to you apparently has a full podcast set up on speaker. You reach over, press a single button on your headphones, and just like that, you cancel all the surrounding noise. How does that happen? Not soundproofing, not foam, not magic. What's actually happening inside those headphones is one of the most elegant applications of physics ever crammed into a $300 piece of consumer technology. Today, we're breaking down the full engineering stack behind Active Noise Cancellation, commonly known as ANC. Stick around, and I promise by the end of this video, you will genuinely fascinate by this technology. Let's start with the science, because this is where it gets mind-bending. Sound is just pressure waves moving through air. Your eardrum vibrates, your brain interprets it, you hear a crying baby. Classic. Now, here's the trick. Waves can cancel each other out. This is called destructive interference, and it's the entire foundation of ANC technology. If you take a sound wave and you generate a second wave that is perfectly out of phase, meaning every peak is matched with a trough, the two waves annihilate each other mathematically. The result? Net zero pressure change at your eardrum. Silence. This isn't theoretical. This is the same physics that makes noise canceling work in everything from aircraft cockpits to luxury automobiles. But generating a perfectly opposite wave in real time, that's the engineering challenge, and it's absolutely brutal. We'll get into that in a bit. If you are enjoying the video, press the like button and subscribe to the channel, and you'll be notified when we upload similar content. So, here's what's actually inside your ANC headphones. First, there's the feed-forward microphones. These are the tiny mics on the outside of your ear cup. They're constantly listening to the world around you, wind, engine noise, HVAC hum, and feeding that audio signal to the processor. Then we have the DSP chip, or the digital signal processor. This is the brain. It takes that incoming noise signal, mathematically inverts it, flipping every peak into a valley, and sends the anti-noise signal to your speaker. All of this happens in under 1 millisecond. For context, the blink of an eye takes 150 milliseconds. This chip is reacting roughly 150 times faster than you can blink. There's feedback microphones. These sit inside the ear cup, right next to your ear. They check whether the cancellation actually worked and fine-tune the signal in real time. This closed-loop system is what separates premium headphones from budget ones. The Sony WH-1000XM5, AirPods Max, Bose QC45, they're all using variations of this hybrid feed-forward feedback architecture. The difference is in the algorithms. Here's where modern ANC gets seriously impressive and where the high-performance audio tech industry is spending billions. Old ANC was good at handling steady, predictable noise, airplane engines, train hum, AC units. Why? Because the DSP could model the waveform and stay ahead of it. But random, transient noise, a door slam, a sudden shout, keyboard clatter, that was always the Achilles heel. Then came the machine learning-based noise cancellation. Companies like Qualcomm, Apple, and Sony have trained neural networks on millions of hours of real-world audio. The AI doesn't just react to noise, it predicts it. It classifies the audio environment in real time and adjusts the anti-noise parameters dynamically. Apple's H2 chip in AirPods Pro 2 runs a computational audio model that recalculates the ANC profile 48,000 times per second. That's 48 kilohertz of adaptive tuning. This is why it can handle something as unpredictable as human speech while still killing background noise. Now, ANC isn't perfect, and the engineering reason why is fascinating. ANC works best on low-frequency continuous sounds, engine rumble, HVAC, road noise. These are long, slow, predictable waves, easy to model, easy to invert. High-frequency sounds, like a hi-hat, a whistle, or consonants in speech, have wavelengths smaller than your ear cup. By the time the mic hears them, the processor inverts them, and the speaker outputs the anti-wave, the original sound wave has already passed your eardrum. The system is physically too slow to cancel it. This is why even the best headphones in the world will still let some treble frequencies through. It's not a flaw in execution, it's a fundamental constraint of physics and the speed of sound itself. So, the next time you press that little ANC button, just think about what's happening. Microphones are eavesdropping on the world. A chip smaller than your thumbnail is doing millions of calculations per second. An AI trained on more audio data than you'll ever hear is predicting the future. And a speaker is generating anti-sound, literal structured silence, milliseconds before the noise would have reached your brain. All so you can listen to a podcast in peace. Noise-canceling headphones aren't just consumer electronics, they're real-time physics engines running on your ears. If you want to go deeper on the signal processing behind this, the math behind destructive interference, or how spatial audio tech ties into ANC, let me know in the comments. I'll build that follow-up. And if you're into the engineering behind everyday tech, things like wireless charging, OLED displays, lithium-ion batteries, hit subscribe because we go deep on all of it. See you in the next one.